Hi, come back to our welcome to ask your topic. So let us discuss today production of rotating magnetic field in induction motors. When three-phase windings are displaced in space by 120 degrees, three-phase currents are also displaced in time by 120. A magnetic flux is produced which rotates in space. Consider three coils located on axis physically at 120 degrees in space. Each coil is supplied from one phase of a balanced three-phase supply. So each coil will produce an alternating flux along its own axis. So here consider phi 1 is phi m sin omega t, phi 2 will be phi m sin omega t minus 120 and phi 3 is phi m sin omega t plus 120. Now this figure shows waveforms of the fluxes that are produced by these three coils. The maximum value of the flux due to any one of the three phases let us consider as phi m. So the positive direction of the flux phases for each phase is shown in the figure. The resultant flux phi r will be calculated now. So when omega t is 0, we will be substituting 0 in all the three equations that are represented previously in this 1, 2 and 3. So now phi 1 will be 0, phi 2 will be minus root 3 by 2 phi m and phi 3 will be root 3 by 2 phi m. So here the phasor for the flux is shown along the OB which is in the direction opposite to positive direction. So here the resultant phasor will be calculated, that is phi r is equal to 2 times of OE. The OD is 2 times OE. So it is 2 into root 3 by 2 phi m into root 3 by 2. So the resultant is 3 by 2 phi m. Now, if you consider omega t as 60 degrees, again substitute omega t as 60 in equations 1, 2 and 3. Now, phi 1 will be root 3 by 2 phi m, phi 2 will be minus root 3 by 2 phi m and phi 3 will be 0. Again, phi r is calculated and the resultant value will be 3 by 2 phi m. And this is the phasor diagram of the resultant phasor phi r when omega t is 60 degrees. Now coming to omega t equal to 120 degrees, you can see the value of resultant phi m is 3 by 2 phi m. Again when omega t is 180 degrees, phi 1 is 0, phi 2 is root 3 by 2 phi m, phi 3 is minus root 3 by 2 phi m and resultant phasor is 3 by 2 phi m. So from this, the resultant flux phi r is independent of time and is a constant flux of magnitude which is equal to 3 by 2 times the maximum flux per phase. That means even if you change the direction of the phasor, you can see the magnitude is constant and which is equal to 3 by 2 times the maximum flux. So with this, I am just ending my lecture on production of rotating magnetic field in an induction motor. I have already uploaded lecture notes on induction motors in our website and I have added lecture notes on basic electrical engineering and DC generators and DC motors also. Thank you.